kidding. Hold up, you got me woke up. The way you roll that, sticky like okra. Just let me coach ya, show you about my culture. It's a late night show like Conan. Bitch, the party ain't over.
Alright, you crazy biocats, Andy here. This is the second time I'm making this video because the first time I did the video was totally wrong and I gave you a lot of misinformation. So this time, I confirmed with JV, who is not here to confirm because I'm doing this in a conference room during an open because, I have a test tomorrow, so this is important for me to know as much as for you to know. So, here we're talking about the dark cycle, the dark reactions, otherwise known as the Calvin cycle. And you're like, Andy, wait, there's dark reactions? Yes, there are dark reactions. You think plants just like do nothing at night? Come on. What are you thinking, man? We're not nothing at night. These are dark. You don't really need light. This doesn't need light. All you need for this, that's right, is CO2. Now I should outline right now. Generally, these reactions will happen in the stroma, in the mesophyll cells. Now, okay, this is not always the case as we have C4 plants, but I will cover that at a later time, in a later video, if I ever get around to it. So actually, no promises on that. So let's talk about what happens here. We need to talk. So generally, this cycle will happen kind of in this order here. But what really happens here is the cycle happens 3 times because you need 3 CO2 molecules, and really only one goes through at a time. Now, I'm really only going to generally outline what happens in a cycle, but keep in mind that when I say a cycle, that's kind of what's happening overall. Like, these numbers are for the overall cycle, but I'm just going to highlight kind of what happens here. Don't worry too much about the numbers. Understand, like, the empirical total of these numbers and how it gets the products, but don't be too hung up over the individual numbers per cycle, because that's not what's important here. It's all about the overall Calvin cycle. So we start with 3 CO2 molecules, and these are catalyzed by an enzyme called Rubisco, and this is like the real MVP enzyme for our reaction here. This does like all the work. Rubisco is like the best. Remember this, know this. No PFK too, which is throwback to cell rest, but Rubisco. We're going to take that, we're going to make, so CO2, 1 CO2. We only really care about the carbon in the CO2. The O2 can go off itself or whatever to go actually be usable too for us. Yay. But CO2, what happens is it attaches to this thing called ribulose biphosphate, which is 2 phosphates on the end of 5 carbons. So then we add this carbon in, and then boom, it's 6 carbons in the middle, and it becomes unstable and splits off, and we make this thing. It looks kind of like a pyruvate, but guess what? It's not a pyruvate because there's a P there. And the actual name of this thing is called a phosphoglycerate. That's the bell, but I'm still going to record anyway. Phosphoglycerate. So that's phase 1. We get CO2, Rubisco, add to the ribulose biphosphate, phosphoglycerate. The ribulose biphosphate is just inherently part of the cycle. It's just there. It's one of your like starting things. Later reactants, really. So now we need to bring in the help of 2 things. We need ATP and NADPH. The ATP is generally created through cell respiration or what have you, oxidative phosphorylation, and light reaction, cell rest, blah, 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 etc. You get ATP. You need 6 of this. Generally, throughout the cycle, you'll need 6 of this for all 3 trials. But once again, overall, you have 6. So we have ATP. So the ATP is going to attach and go to ADP by taking off a phosphate and giving off energy, and attaching it onto our phosphoglycerate. Okay, I'm never gonna memorize that one. Phosphoglycerate. The name's not important at all. But so then we get like phosphoglycerate with another P on it. So it's like poop, but with 3 O's, which are actually carbons. But poop. So then we need the NADPH, which we created in the light reaction, if you remember from the previous video, which you should remember, but I was talking really fast. But anyway, NADPH to poop. Now, NADPH will reduce to NAD+. Now remember, overall, we will have 6 NADPH throughout the 3 CO2 molecules that we use in the cycle. But all you need to know right now, NADPH will give off a pair of electrons, thus detaching the phosphate that you added through the ATP reaction, and then creating another 3-carbon molecule called G3P, or glyceraldehyde 3-phosphate. And you're wondering, Andy, why is this different from phosphoglycerate? Well, it's different because that pair of electrons oxidizes the carbon, so you get like a different form. Alright, just know that these are 2 different things. Despite being a phosphate attached to 3 carbons, the molecules are inherently different because of the nature of the reduction from NADPH. So with this, you get these, and then overall you'll create 6. Now, this total cycle, the whole goal of having these 3 CO2s do all this stuff, is that you can eject 1 G3P. And this G3P will go to important stuff, which is basically like, as far as we're concerned, making glucose. It makes other stuff, but you know what all J. Bay really said was it makes glucose. So it makes glucose. That's what it makes. Nothing else matters. Okay, so we're going to take this stuff and we're going to go, so that's phase 2 right here, to make G3P. We go from Bisco to this thing, now to G3P. Now, well, if you can, overall in the cycle, only 1 G3P gets made, which means, and there's 6 G3P made, and one G3P is ejected, but 6 are made. So then what happens to the other 5? So the other 5 G3P will go, and we'll need another 3 total outside ATP to go to ADP to give us phosphates again. And then we'll merge them back together, and we will create our ribulose biphosphate molecules. And this will give us the inherent amount that we need to really start this cycle. You know the 5 number? Though, I mean, yeah, technically 5 ribulose biphosphates are made, though, I think. No guarantees. Ignore that number. But you make ribulose biphosphate, and that's how the cycle really goes. So, at the end of it, you're going to have some leftover G3P, and that makes the ribulose biphosphate that you need to really start the next cycle to react with the catalyzed CO2s and stuff. That's the video. Hope you enjoy it. Click like and subscribe. Yeah.